starting here with part 1. Use a scale to measure the mass of the boat. I am using a Tupperware container for my boat, just to do a test. And it's just a regular, like a lunch meat container. And I measured the mass of it, and the mass is 0.019 kilograms. So just write that down in your paper. I'll just write all these things down. I found the length, the width, and the height. Okay, the length, the width, and the height were 0.145 meters. These are all in meters, by the way. Width is 0.125, and the height was 0.05. So when I multiply those together, I got 0.00091. So I need to know the mass and the volume, and I could use that to figure out the density of my boat, just to prove that it would float. But I'm definitely going to get a number that's less than, I'm definitely going to get a number that's smaller than 1,000. So let's do that real quick. So when I do the density of the object, I get what did I do? 0.0919 divided by 0.00091. I got 20.9 for the density. Okay? So it'll definitely float. That's way less than 1,000. 1,000 is the density of water. So draw a diagram of the boat floating in the water, label the forces, and then think about Newton's second law. So here is the water. Here is my boat floating in the water. It's just a rectangular container. And the forces that I have are gravity down, buoyant force up. Okay, so because it's floating, we know the buoyant force equals the force of gravity because the acceleration is 0. So buoyant force minus gravity equals 0, so they equal each other. Okay, the boat will sink if the density of the boat equals or exceeds the density of the water. Since the volume of the boat is fixed and cannot change, the only way to increase the boat's density is to increase the mass. Calculate how much mass the boat can hold before it sinks. Some things to keep in mind: that the density of water is 1,000, and you need to account for the mass of the boat. So here's what we're going to do. We're going to start with this. The buoyant force equals the force of gravity. So the buoyant force is the mass of the displaced fluid times gravity. That's the buoyant force equation. Equals the mass of the object times gravity, which is the gravity equation. G's on both sides, so G cancels. So we get mass of the fluid equals mass of the object. So the masses are going to equal each other. So all I need to finish this off is figure out how to get this mass together. And since the masses are the same, I can deal with them interchangeably. And so I'm looking at this and I'm saying, oh, okay, I'm solving for mass. I know the volume. I know the density of water. So let's just do density equals mass over volume. The density that I know is water. It's 1,000. The volume of the water will be equal to the boat, and that is 0.019. Okay? And the mass is what I'm solving for. Specifically, it's the mass of the weight. So I'm going to add the boat's mass. Oh, wait, I wrote the wrong thing down here. That's my bad. The volume was 0.00091. The mass is 0.019. Plus the mass that I'm solving for. Okay, All I need to do to solve this is multiply the volume to both sides. When I do that, I get 1,000 times 0.00091. And then I'm going to subtract the 0.019 over. When I do that, I get the mass equals 0.891. That's how much mass my boat should hold. So, come with me, ladies and gentlemen, to the back. No, you can leave your papers where they are. Just come to the back. Let's see if it actually works. All right. Come around, come around, come around, come around. There we go. We're going to see if it can hold 891 grams. So that was 0.891. So I'm going to start with 500. Right in the middle-ish. Hopefully. Oh, nope, it's not the middle. There we go. Okay. 891. Let's see, we got the 200 in somewhere. Here's the 200. There's the 200. Okay, so this will get us up to 700. Ooh, okay. That gets us to 700. Let's put a 100 here, see if we can get to 800. Try to balance it. No! Oh, it's sinking. We made it last year. No, the equation is not wrong. No, the problem is I'm not getting it. I'm not getting it balanced right. All right, I'm gonna have to do less weight. That's okay. It'll still be fun, probably. I also think it's partly because my no, stop it. Look at this ruining. It's all right. Last period, I totally screwed up in that, so this is better than that. All right, let's do a 50. There we go. So now we're at 750. Let's do a 20. 770. Oh, no, it's starting. It's starting. Oh, but it hasn't gone yet. There we go. 770. All right, go have a seat. Let's see how well we did. So we calculated we would do 890. It held 770. So that's disappointing. I got all the way up. I got all the way up to 800 in the last period. Okay, so on the back, add the calculated mass to your boat a little at a time. Write down the amount of mass the boat holds and calculate your percent air. So the amount of mass it held was 0.77. There we go. So the equation for percent air is here at the bottom. It's expected minus measured divided by expected times 100. So I expected to get 0.891. I got 0.77. I expected 0.891 times 100. Okay, minus 0.77 divided by 0.891 times 100. I got 13.6% error. We always count accuracy as being less than 20%. So I got less than 20% error, so this is accurate. So even though it seems like I got a lot less mass, I'm still pretty close to what I thought I should get. So this should show you that absolutely, yes, you can calculate how much mass, and you should be able to get close. So you guys are going to make your own little boats. but you're going to use this exact same principle for the big boats you're going to do. So here's the equation that you're going to need. Density of the fluid equals mass of the boat plus whatever the other mass is divided by the volume of the boat. There you go. That's the equation you're going to use. So you're going to build a boat. Once you build the boat, you're going to measure the volume the way I did. Do whatever shape yours is, measure the volume as best you can. Okay? The density of the fluid is water, which is 1,000. Okay? Then you're going to add the mass of the boat to what you're going to solve for, which is the mass of the object. You're going to do the exact same thing when you do your boat. You'll estimate about how much your boat weighs. You'll figure out the approximate volume of your boat. The density will be the density of water, and you'll solve for little m. Solve for the mass that the boat can hold. And if that mass is higher than your mass, then you're good. Now, you'll want to give yourself a little bit of leeway, right? If your boat says it can hold 180 pounds and you weigh 180 pounds, that's probably not great because you're assuming 0% air then. Okay? But if you weigh 180 pounds and your boat says it can hold 250, you're probably in good shape. That's within 20%, 13% air. So today you're going to try to make your own little boat. You're going to see how you do. You're going to do the best that you can. You're going to build your little boat, and then you're going to take it to the back, and you're going to try to see how much weight it can hold. Okay? Once you've done that, you're going to calculate your percent air. Okay? And then you're going to figure out a score, because we're going to get a winner. Okay? The way you calculate your score is you take the mass your boat held, and you're going to multiply it by 1 minus your air value from number 8. So whatever you get for your percent air, you're going to do 1 minus that. Okay? And you want to do that in decimals. You don't want to, so in other words, before you multiply it by 100. So just the percent air before you multiply by 100. But when you get to the score, I can help you do that. It's very easy. Okay? And then we'll see who the winner is. So basically, you want to make a boat that holds lots of weight and is accurate in how much weight it can hold. So if you're not sure it's going to hold a lot of weight, it's better to make a boat that's more, that won't hold as much, but will have a good percent air. So either way is fine. Just do the best that you can and go from there. There is tin foil in the back, so come on to the back and grab a piece of tin foil. Everyone grab one.
Best experience I have is creating a huge.
Anyone else still need a lot of volume?
We gotta make a boat.
Once you're done with your boat, do the math. If you need help with the math, let me know. Once you've done the math, you can come back and test your boat.
Do it, man.
As per usual, your grade's not being done on how good your boat is. Just do the best you can, and then